The universe is a vast place full of mysteries that challenge our imagination. It's a cosmic ocean filled with swirling galaxies, exploding stars, and invisible forces that shape the fabric of space and time. Today, we are going to explore the most incredible and impressive cosmic events ever recorded in space. Events that make our planet seem like a tiny speck in a grand cosmic ballet. From the birth of stars to the death of galaxies, we'll witness the awe-inspiring power and beauty of the universe. We'll journey to the edge of black holes, where gravity is king and time itself stands still. Get ready for a fascinating journey through the cosmos. Fasten your seatbelts, because we're about to embark on an adventure that will expand your mind and leave you breathless. Imagine a universe not static, not even slowly growing, but one where the very fabric of space is stretching and expanding at an ever-increasing rate. This discovery, which earned the 2011 Nobel Prize in Physics, shook the foundations of cosmology. For decades, scientists believed that the expansion of the universe, a consequence of the Big Bang, was gradually slowing down due to gravity. However, in the late 1990s, astronomers observing distant supernovae discovered something astonishing. These supernovae were dimmer than expected, meaning they were farther away than our models predicted. The universe wasn't just expanding, it was accelerating. This discovery implied the existence of a mysterious force, a sort of anti-gravity, that we now call dark energy. The implications of this discovery are profound, suggesting a universe growing colder and darker as galaxies are pushed farther and farther apart. In the vast expanse of the universe, few objects shine as brilliantly as quasars. These cosmic powerhouses are the most luminous objects we've ever observed, some shining with the light of 1 trillion suns. Imagine a black hole, millions or even billions of times the mass of our sun, sitting at the heart of a distant galaxy. This isn't just any black hole. It's a cosmic glutton, devouring anything that ventures too close: gas, dust, even entire stars. As this material spirals into the black hole's gravitational grip, it forms an accretion disk, a swirling whirlpool of superheated matter. The temperatures and pressures in this disk are so extreme that they generate intense radiation, spanning the entire electromagnetic spectrum. These beacons from the distant universe are so bright they can outshine their entire host galaxies. Studying quasars provides us with a glimpse into the early universe, allowing us to probe the conditions that existed billions of years ago. We often associate the aurora borealis with our own planet, but did you know these light displays aren't unique to Earth? Auroras have been observed on other planets, even more spectacular than ours. Jupiter boasts the most powerful auroras, generated by its strong magnetic field. Saturn also puts on a dynamic auroral show, changing rapidly with the solar wind. Deep within the heart of a supernova remnant, a dying star undergoes a dramatic transformation. It collapses under its own gravity, squeezing its core into an object so dense that a teaspoonful would weigh billions of tons. This cosmic ember is a neutron star, and some of them spin with unimaginable speeds. These are the millisecond pulsars. Imagine a sphere only about 12 miles across, rotating hundreds of times per second. These objects are like cosmic lighthouses, emitting beams of radio waves from their magnetic poles that sweep across space as the pulsar spins. The precision of these pulses is astounding. Some millisecond pulsars are as accurate as atomic clocks, making them the most precise timekeepers in the universe. They are thought to be spun up by accreting matter from a companion star, causing them to spin faster and faster. Millisecond pulsars are valuable tools for astronomers, used to study phenomena from gravitational waves to the structure of our galaxy. In the vast emptiness of space, galaxies may seem like islands of stars, separated by unimaginable distances. But the universe is a dynamic place, and even these cosmic giants are not immune to the pull of gravity. In fact, galaxy collisions are a surprisingly common occurrence. Imagine two spiral galaxies, each containing billions of stars, slowly drawing closer together. As the galaxies approach each other, their gravitational fields distort their once symmetrical shapes, drawing out long tails of stars and gas. These tidal tails can stretch for hundreds of thousands of light years, creating cosmic bridges between the colliding galaxies. Eventually, the galaxies plunge into each other, their gas and dust clouds colliding head-on, triggering a burst of star formation. Over millions of years, the two galaxies merge, their individual structures blending together to form a single, larger galaxy. For centuries, we've explored the universe with telescopes, capturing light from distant stars and galaxies. But the universe speaks to us in other ways, through ripples in the very fabric of space-time called gravitational waves. Imagine space-time as a vast, flexible sheet. Massive objects, like stars and black holes, create indentations in this sheet, much like a bowling ball placed on a trampoline. When these massive objects accelerate or collide, they create ripples in space-time, gravitational waves that propagate outward at the speed of light. In 2015, the Laser Interferometer Gravitational Wave Observatory, LIGO, made history by detecting gravitational waves from the merger of two black holes. This groundbreaking discovery opened a new window into the universe, allowing us to study some of the most energetic events imaginable. Gravitational wave astronomy holds enormous promise for unraveling the mysteries of the universe. Our sun, a star we often take for granted, won't last forever. Like all stars, it has a life cycle, and its eventual demise will be spectacular. Before that, it will produce breathtaking objects called planetary nebulae. As it exhausts its fuel, it sheds outer layers into space. This forms a glowing shell of gas and dust, creating colorful patterns. The Ring Nebula is a famous example, about 2,000 light-years away. Imagine the most powerful explosion you can fathom. Now, multiply that by a factor of 1 billion, and you might begin to grasp the sheer power of a gamma-ray burst. These cosmic events are the most luminous explosions in the universe since the Big Bang itself. Gamma-ray bursts are brief but incredibly intense flashes of gamma rays, the highest energy form of electromagnetic radiation. These bursts are detected by satellites orbiting Earth and can last for a few milliseconds to several minutes. The source of these cataclysmic events remains a mystery, but astronomers believe they are associated with the collapse of massive stars or the merger of neutron stars or black holes. These events release an unimaginable amount of energy, equivalent to the energy output of the sun over its entire lifetime, in just a few seconds. At the center of our galaxy, hidden from our view by swirling clouds of gas and dust, lies a monster, a supermassive black hole, a gravitational titan millions of times the mass of our sun. Astronomers believe supermassive black holes reside at the heart of almost every large galaxy. These cosmic behemoths have gravity so strong that nothing, not even light, can escape. They grow larger over billions of years as they consume gas, stars, and anything that ventures too close. For stars much more massive than our sun, the end comes in a spectacular explosion that briefly outshines an entire galaxy, a supernova. These cosmic cataclysms are among the most violent and energetic events in the universe. Imagine a star, at least 8 times more massive than our sun, nearing the end of its life. The core collapses inward, triggering a runaway nuclear reaction that rips the star apart in a blinding explosion. For a few weeks, a supernova can outshine billions of ordinary stars. Its light echoes across the universe, carrying with it the elements forged in the star's core during its lifetime, and in the crucible of the explosion itself. Supernovae are essential for the evolution of galaxies and the universe as we know it. The universe is full of mysteries and wonders that leave us fascinated. From the accelerating expansion of the universe to the explosive death of stars, we've witnessed some of the most incredible cosmic events ever recorded. Which of these events did you find most incredible? Was it the unfathomable power of quasars, the breathtaking beauty of planetary nebulae, or the sheer violence of a supernova? Let us know in the comments. And if you love space curiosities, don't forget to like, subscribe to the channel, and hit the bell for more videos like this. The universe is vast, and there's always more to explore.